Hi everyone, let's talk about some calculus. Specifically, we're going to talk about what exactly is a derivative. So, the motivation for derivatives comes from the very simple idea we know the slope of a straight line, right? Y equals mx plus b. We know the slope is m. It's a constant, rise over run. We know that very, very well. But what is the slope of a curve? That's a question we don't necessarily know the answer to, and that's where derivatives come in. So the definition of a derivative is it's the instantaneous slope of a function. So it's the slope of a curve at a specific point. Sometimes we'll refer to it as the rate of change of the function. So as we can see in this picture here, right, the black line is our curve that we're looking at, and this red line shows you the slope at the point right here. So this is if we had a straight line with the same slope at this point, this is what it would look like. So the formal definition is, of course, it's math, it's fancy. It goes like this. The derivative of a function f of x at the point x equals a is defined as the limit as delta x approaches 0 of f of a plus delta x minus f of a all over delta x. We write this as f prime of a. So the prime means our derivative. This is super fancy. If you've ever had to do this before, you know it's terrible. We have a lot of simpler rules we'll cover in other videos. But the basic idea is we're changing our x just a little teeny tiny bit, this delta x. And we want to see what happens to the change in y, the change in our function value. So that's what the top is. The top is our change in function value. The function value at our slightly to the right point minus the original function value all over that tiny distance we traveled. And as that goes to 0, that's going to tell us what the instantaneous rate of change is. That is the derivative. It's that at every single possible point that we could want to look at. So we'll see you in our next video to talk about some tips and tricks to make derivatives a little bit easier.